Now, just like we did with congruency, we're going to learn how to prove with certain postulates and theorems about similarity. Yes, we are going to talk more about proofs. We're going to go back and revisit proofs, and in this case, or in the following situations, instead of proving that two figures are congruent, we are going to prove that they are similar. It's actually very similar to the same process, except for we're going to be using different postulates because we're talking about a different concept and we're trying to prove different things. So our ultimate goal is to see if two figures are similar or not. We're going to start with triangles, focus on triangles, and these three postulates are used to determine if triangles are similar. The first one is the side angle side similarity postulate. Try to write these down. You can screenshot it if you want or snip it. I highly suggest you write it. I think it helps you cognitively understand it better. When you slowly read, understand, and then transform it into writing, your brain is retaining the information a lot better. So if a pair, the first postulate we have is the side angle side similarity postulate. If a pair of corresponding angles is equal and the sides including them are proportional, then the triangles are similar. So that's actually similar to side angle side congruence postulate. The second one is, and don't worry if you don't understand them, we're going to walk through them visually as well. The AA similarity postulate. If two pairs of corresponding angles are equal, then the triangles are similar. If two pairs of corresponding angles are equal, then we know the third pair of corresponding angles are also going to be equal. And since all of them are equal, we know that the triangle has the same basic shape. It's just that the side lengths may be different. The side similarity postulate. Now this seems similar to the side congruence postulate, but it is not. Instead of all three sides having to be congruent, the side similarity postulate states that if three pairs of corresponding sides are proportional instead of congruent, they are proportional now, then the triangles are similar. For example, this is an example of the side angle side similarity postulate. Notice how we have a side here. Whoa. We have a side here. We have a side here, and we have a side here, and then they have an angle in between them that is congruent. So angle A is congruent to F. And what the side angle side similarity postulate states is that if I do have that angle, so I have a pair of corresponding angles, and the sides including them, which means the sides that make up those two angles. So for in this case, AB is corresponding to EF. Oops. Gotta erase that part. And that ratio, if they're going to be in proportion, should be equal to the ratio between AC, which is 4, and DF, which is 6. So that has to be equal to AC to DF. So I'm finding the ratio of each pair of corresponding sides, and they have to be equal to each other. So AB to EF is 8 over 12, which is 2/3, and AC is 4, so AC to DF is 4 over 6, which is also 2/3. So yes, those two corresponding sides, those two pairs of corresponding sides have equal ratio, so they're in proportion with each other. So those two sides are proportional, and the angle in between them is congruent, so you can use the side angle side similarity postulate. All right. Next is the angle angle similarity postulate. If angle A is congruent to angle F, and angle C is congruent to angle D, that means angle E must be congruent to angle B. Why? Because these both add up to the same number. And we know that 180 degrees is the sum of the interior angles of a triangle. So if I subtract the sum of AC from 180, I'm going to get the same number I would get if I would get the same number if I subtracted D and F from 180, because angle D and angle F are congruent to angle C and angle A. And if all three angles are congruent, that means the triangles, their side lengths will always be in proportion. So therefore, the triangles would be similar. And last but not least, the side-side similarity postulate. If all three sides are in proportion to each other, then you can know that the whole triangle is in proportion to each other, and that all the angles are congruent as well. So in this case, see, we would have 9 to 27, which would equal 1/3, and we'd have 7 to 21, which would equal 1/3, and we could have 13 to 39, which also equals 1/3. And for all three sides
live class perhaps
have the same proportion, therefore the two triangles are similar.